Okay, good morning, guys. Really quick, we're talking about moon phases and tides and eclipses, all of which are based on the moon rotating on its axis and revolving around the Earth. Rotation is when something spins on its axis, where revolution means it travels around a fixed point. For example, Earth rotates one time in 24 hours. That is why we have day and night. Earth also revolves around the sun in 365 days, roughly. So with that in mind, if you get rotation and revolution confused, pop open your reference table. On page 15 there is the solar system data chart, and you can notice that it says period of rotation and period of revolution. And if you look at Earth, you should be able to understand or notice that a revolution is 365 days. So a revolution is a year, and a rotation is a day. So that's a good helpful hint if you can't remember the difference between rotation and revolution. So pop open your reference table. Now, in terms of why we always see the same side of the moon and why the moon has phases, that's due to a few things. First, we always see the same side of the moon due to what we call synchronous rotation, or essentially it rotates and revolves at the same rate, which is 27.3 days. You'll notice that on your reference table. Now, because of that, the moon is rotating a little bit every time that it's revolving around the moon. So let's see what happens if this was not the case. So really quick here, you're going to notice the red side of the moon is what we see. And if we did not have any rotation, if you notice the moon is not rotating, it is only revolving around the Earth. So during one cycle, you should have noticed that we saw all sides of the moon, the red side and the white side. That is not the case. We always see the same side of the moon. So let's see what happens. Right now the moon is rotating much faster than it is revolving. And if you notice, it's rotating probably 10 to 20 times in the same amount of time that it takes to revolve around the Earth. That's not actually what the moon does. In this case, we would again see all sides of the moon. This animation shows what happens. As the moon is rotating slowly, it's also revolving at the same rate. So if you notice, every few degrees, the moon tends to rotate a little bit. And for that last animation, we only saw the red side of the moon, which is the side that we see. We call it the light side of the moon, or the front of the moon, because we can't see the back of the moon from Earth. All of our pictures from the back of the moon come from outer space, come from the International Space Station and other satellites. All right, so most important thing is we always see the same side of the moon because it rotates and revolves at the same rate. Now, if we look here, we can also see what happens with the illuminated portion. If we notice, I'm just going to fast forward here. It doesn't matter if the moon is in this position. My internet isn't working the best. This position. In every case, 50% is illuminated. However, we don't always see half of the moon in terms of a first or second quarter. We only see, what's only visible to us is the illuminated portion. So in this one moment of time, if we were to be standing on the Earth and we were to look at it, we would notice that on the right-hand side, if you notice, is dark. It's shaded. That is because the sun's rays are being sent out. It's illuminating the front half, and the back half is in the shadow. So the right-hand side in this case is darker. The left-hand side is lighter. And watch what happens as this moon travels across the Earth when it's illuminated. You notice that in this case we see no moon. At this moment in time, if we were to look at the moon, we would actually see this one quarter illuminated. The other quarter that we can quote unquote see is invisible, and that's because it's the shaded portion. So if we were looking at this moon, we would see a quarter. And if it continues, it continues around until this position. And this might be a little weird to look at because usually if an object is behind another, it is completely in its shadow. However, the sun is much larger than the Earth, which is also much larger than the moon. So these sun rays are actually traveling past Earth and hitting the moon. So at this moment in time, we actually see a full moon, and you can notice that the entire portion we see is red. Imagine, again, standing here, you're looking at both sides of the moon. You see a red illuminated side on the left, red illuminated side on the right. That means from right to left, you'd see a complete full moon. That moon continues on its path, and if you notice now in this position, if we were to look at the moon, we still have 50% illuminated from the sun, but our line of sight, our visual, is again only the red side. So we only see this quarter. The other quarter that is technically viewable is invisible, and that's because it's in the shadow. So this would be another quarter phase. And as the moon continues to work its way around, we then get to what we call a new moon, which is when we do not see the moon. I'm going to put this animation in with the notes, and this is a great helpful hint as we do moon phases. Take your time with this stuff, guys. It can be a little confusing. Remember that waxing means that the moon is getting brighter, and that is what's happening from this new moon phase all the way to a full moon. It's growing in illumination. We go from seeing no moon to quote-unquote our visual is 100% of the moon, even though 50% is technically in the shadow. And then at the full moon phase, so I'm going to, again, if I go, let's see, right about here. So now it's grown completely. We see a waxing moon, and then now it's going to start to disappear, meaning that the illumination or the illuminated side or portion is going to decrease to the human eye. So at this point, we now are seeing that red section decrease until back to a new moon, and that is the waning phase. Waxing gets brighter, waning gets dimmer. All right, let me know if you have questions, guys.